I'm back now. So we are in chapter 2, circuit elements, definition relations and definition relation of those elements. And we were examining the ideal elements. We examined sources first and the resistors as second group of elements. And the last group is open and short circuit elements. Let's go in detail. Short circuit element is a piece of wire between those two terminals is a short circuit element. This short circuit element voltage is equal to 0. So that's the definition relation. So that means if you take a piece of wire and connect between two terminals and measure the voltage between these two terminals, you're going to measure that 0 volts. But there could be a current passing through. Voltage is 0 doesn't mean that current is 0. So there could be a current passing through. So how this current is going to come? Because we are considering these A and B terminals within a circuit. So if we connect those two specific terminals with a wire, so the other part of the circuit is going to drive a current from A to B or from B to A. So there could be electrons passing one side from left, right, left. So current depends on the circuit it is in, that wire in. There is no relation between its current and voltage, no VI relation. So VAB equal to 0 is only. Another element that we're going to see here is the open circuit element. The open circuit element, if you take off a wire like that, then that means A and B terminals are open circuit. That means there is no electron coming from A going to B and the vice versa. That means no current passing. Then current is equal to 0. But it doesn't mean that the voltage between these A and B terminals is equal to 0. This voltage depends on the circuit that A and B terminals are in. So there is no relation between its current and voltage, but definitely known when it is open circuit element, the current is 0. Voltage, you could measure a voltage. You can put a voltmeter hand and measure the voltage. Now, why we said those two? These are the very critical elements, because these elements helps us to represent the on-off switch of all the electrical equipment. If you consider an on-off switch is like that. So if the switch is in position 1, it is a short circuit. If it is in position 2, it's an open circuit. How it works? So if your on-off button on your equipment is off, then you are in position 2 and no current passing through from A to B. So that means the power, if the power independent power source is connected to A and that's open, so there is no current passing to the circuit. If the current is 0, then power is 0, so no power is transferred to B or to your equipment, so electrical equipment. But if you connect if you put that switch to the position, when the switch is on, that means position 1, so you made this short circuit, so that means your independent voltage source is applied to the terminal B. So this source delivers the required color to your electrical equipment. So this is a nice explanation of the on-off switch is the short and open circuit elements for each position. When a resistor is short circuited, that means you're going to connect two terminals of a resistor with a wire. Both its current and voltage become 0. That means resistor is removed from the circuit, because the current open circuit, no current, means you're going to remove this resistor from the circuit. When the control variable of a dependent voltage source is 0, then this element is short-circuited because the voltage of this dependent voltage source is going to be 0 because the control input is 0. Multiplied with the coefficient, you're going to get 0. Therefore, it's going to be short-circuited voltage source, dependent voltage source. If it is dependent current source and the control variable is 0, then dependent current source current is going to be 0. That means open-circuited. It is dangerous to connect a wire between a dependent source terminals short-circuited. This causes electric shock. So if you connect a piece of wire between the terminals of your mains in the wall, that means there is a voltage there and you are forcing this voltage to be 0, so it's going to be electric shock. So don't do it. Be careful. So look at the whole picture once more. So we said we've got circuit elements. We are defining these circuit elements by using the definition relations. These circuit elements, ideal elements, sources, resistors, and open short circuit elements that we have seen up to now. The next step, we will be examining the circuit elements classification.